Hello, this is Aakash Gupta. I am the CEO of ThinkEvolve Consultancy. And in this paper, my team has proposed ProdRev, a DNN framework for empowering customers using generative pre-trained transformers. Users on e-commerce website often use the reviews for understanding the quality of the product. However, there can be thousands of reviews with conflicting information. This results in decision paralysis due to a barrage of information, what is known as information overload. Large number of conflicting reviews confuse the reader. This scenario disempowers the consumer since they cannot comprehend large set of disparate information. Commercially available tools provide an adjusted scoring mechanism to alert users to potential review manipulations. However, in this paper, we have introduced a framework to induce common sense and enable better decision making. We have also created a novel data set through manual annotation for understanding these reviews. By fine-tuning GPT-3 for our use case, we introduce abstractive summarization instead of simple extractive methods. The output of this framework is a set of pros and cons for the product along with the overall verdict. Using these outputs, the customer can then make an informed decision. Let's now define the problem statement. Humans in general tend to use short-term memory for reviewing information and making decisions. So it's difficult for us to comprehend large amounts of disparate information. The situation leads to poor decision making, suboptimal choices, and in the end, it disempowers the customer. Our research proposes a framework for homogenizing all the review information. The proposed framework aims at minimizing misleading machine verdicts. By providing transparent summarization of the reviews as pros and cons, the user can make their own choices. Literature review shows us that generative pre-trained transformers can identify semantic and syntactic features through an attention selective mechanism. In the paper, language models are few-shot learners. Authors have trained 175 billion parameter generative model. This performs outstanding well on various natural language processing tasks and other benchmarks. The paper also discusses the various ways where the model can be turned into a zero-shot model for a specific purpose. This also provides us with SOTA-level performance. In the research article GPT-3, its nature, scope, limits, and consequences, the authors have run tests to understand the performance of the model for logico-mathematical, semantic, and ethical requests. Such third-generation transformer models use deep learning techniques and can produce text at par with humans. The paper also discusses the ethical questions arising from the use of such powerful models. Also, examine how fine-tuning of GPT-3 models can be used for specific tasks like summarization of Russian language text. This is even when the original model was not trained on that specific text corpus. So, by extending the standard transformer architecture with attentive selective mechanism, we can achieve state-of-art performance on predicting distinct relationship with very high confidence. In the proposed methodology, we have fine-tuned a GPT-3 model which is made available by the team at OpenAI. For our research, we have created a novel data set using human annotators. Each row in our dataset contains unique reviews for different products. The reviews are then summarized into pros and cons by a human annotator. Final verdict is generated based on the sentiment of each review. The reviews are then structured to create prompts which enable the fine-tuning of a GPT-3 query model. A content filtering mechanism is also set up to meet OpenAI's terms and conditions regarding toxic content. This architecture helps the user to get a clear understanding of the product reviews by summarizing and clustering the reviews into pros and cons. In the next section, let's understand the dataset preparation and the training process.
Dataset preparation. The dataset chosen was of reviews about various products that were fetched from the AWS S3 bucket after configuring the concerned AWS account. After pushing all the S3 bucket contents from the cloud to the local drive based on product category, the files were sorted out. K-means clustering has been deployed to the cluster reviews of the same kind such that the reviews of different products don't get mixed up. Finally, the files of different clustered products categories were concatenated to create the final dataset. The dataset created consists of 70,963 rows, each having 15 reviews. Each row in the dataset can be treated as 15 reviews for a single product. Since the reviews were taken from the public domain, it is necessary to see if the reviews were safe in terms of ethical, political, and religious sentiments. So, for this content filtration, it is necessary to pass each review through a filtration function as provided by the OpenAI platform that labels each review as 0, 1, 2, corresponding to safe, sensitive, and unsafe content. Fine-tuning the GPT-3. The above figure here shows the structure of the prompt that has been used for the fine-tuning purpose. In the original dataset, the 15 reviews were joined through the string. Here you can see /n/n, 6 stars, and again /n/n, such that the desired structure of the prompt gets created. The structure of the prompt is not hard-coded. It can be changed depending upon the principles of prompt engineering. The completion section creation was rather a difficult task that has been manually done through human annotators. There was a manual annotation of each review corresponding to the structure of the completion section. The deployment of human workforce made the annotations comprehensive and generative rather than extractive summary. Such actions contributed towards human-level machine performance. That is, the completion part generated by the model resembles human-level performance and accuracy. The completion part consists of 3 parts: pros, cons, and verdict. Making these 3 sections available to the user makes it comprehensive and helps the user to make an informed decision within a short time. Once the prompt and completion.csv file is ready, the next in line is to convert the CSV files to JSONL file. For fine-tuning purpose, OpenAI allows only .jsonl files. Once the JSONL file was uploaded, next in line is the final fine-tuning job. The generative pre-trained transformer is now trained on a particular dataset for a very particular purpose. This step is the final leap where the transformer learns about what sort of output it needs to generate when fed with a particular prompt. The hyperparameters for training the transformer was selected as such in the table shown. You can see for our fine-tuning purpose, we have chosen engine as our query, best size 49, epochs 5, learning rate 0.1, and use padding equals to true. Now, use padding equals to true is something that we often keep as Boolean true whenever we are not performing any kind of classification task. Otherwise, it would have been false. Now, result analysis. In order to analyze the performance of the model, it has been put through a lot of tests and training in order to make it more robust and better at producing desirable outputs. The final trained model that has been fine-tuned on 485 data points was deployed in a real-life use case, where there was heterogeneous information about a particular product, and the model was meant to generate a homogeneous output along with the final verdict. The figure on the left clearly depicts how well the model performs in generating a homogeneous completion section, which is not only precise but highly comprehensive in nature. Such output always allows user to view directly the nitty-gritty of a product. The model also produces a final verdict depending upon its own understanding about the pros and cons, thus providing greater assistance to the user in decision making. Further analysis of the training procedure included calculation of performance metrics in order to understand a trend in the training process versus the training data. In order to do so, BERT score was calculated as it deploys similarity of the tokens through contextual embedding. Following the trend, the final model was trained upon 485 dataset that performs pretty well. The calculation of BERT score involved various trained data size in order to estimate how much of training can produce desirable results. However, from the figure on the upper right, it can be clearly seen that even with small data size, the fine-tuned model performed pretty well. Log score analysis was also carried out in order to support the results produced by the BERT score analysis as in figure on the lower bottom. Consider the demand of the proposed methodology. Unigram log score was considered in order to estimate a trend in the training process. The decrease in log score can be understood from the fact that ROGS uses unigram matching of words rather than the context or sense of the generated output. However, it confirms that it has been followed for training and fine-tuning of the transformer. The methodology present in the paper is highly robust and efficient in comprehending and producing a homogeneous compression section that becomes easy for human brains to perceive. The model also produces quite an accurate verdict depending upon its understanding of the pros and cons, thus providing higher assistance toward decision making. The final verdict also allows the user to see whether his or her decision from the pros and cons is good or bad or near to the machine level performance. So definitely it does help in making individual decision by the user as it provides the final verdict along with the pros and cons. Now we are open to any questions regarding the topic discussed. Further extended queries, please feel free to contact the corresponding authors through the given emails. Thank you very much.